This is a related rates problem. So we have this little balloon over here, and the volume of that balloon, we're going to assume that it's a sphere, is 4/3 pi r cubed. You should probably know that. So what's happening is we're going to have this balloon, and we're going to be inflating it at a rate of 5 cubic inches per minute, which basically tells us that the derivative of the volume with respect to time is equal to 5. So dV dt is equal to 5. So we're going to take our volume and we're going to differentiate in respect to time. So if we took the derivative of v with respect to time, we get dV dt. And the 4/3 is going to give me 4/3 times the 3 using the power rule is 4. Keep the pi, 4 pi r squared. But then I'm going to have dr dt. So what we're going to do is we're going to solve for dr dt, because that's going to give us the rate of change in reference to the radius. So the derivative in terms of the radius with respect to t. All right, so we'll divide by 4 pi r squared. And really that's 1 over 4 pi r squared times dV dt equals dr dt. So we solve for dr dt. That's the rate at which the radius is changing. And we got all this. Now we already know that dV dt is equal to 5. And what we're looking to find out is what's happening when the radius is 1. So I could then plug in 1 for r. So 1 over 4 pi times 1 squared times the 5, which would give me 5 over 4 pi. Which the decimal equivalent would be 0.397887. So I'm going to say 0.398. And that is inches per minute. All I have to do then for the other radii is just plug in the values. So if I just did 1 over 4 pi times 1.5 squared times 5, and then the last one would be 1 over 4 pi times 2 squared times 5, and I'll get my decimals out. Okay, so I just typed those into a calculator, and I got 1.77 inches per minute and 0.099 inches per minute. So what's really happening is when you start to blow up a balloon at a constant rate, probably using some sort of air compressor, when you first start blowing up the balloon, the volume increases by that 5 cubic inches per minute. When the balloon is small, the radius has to get much larger to incorporate those 5 cubic inches per minute. As it gets larger, it takes less increase in radius to account for the increased volume.